Right, 4 wooden struts are used to support a platform which carries a load of 20 kilonewtons. So the load equals 20,000 newtons. Now we have a platform with 4 legs. 1, 2, this is bad how drawn, but with 4 legs. So the load per leg will be 20 divided by 4. That would give us 5,000 newtons. That's the load per leg. The timber has an ultimate tensile strength of 21 meganewtons. So the ultimate tensile strength is 21 by 10 to the 6 newtons per meter squared on average when tested. Calculate the cross section, right, of area. So that'll be involved when we get the area, and then we can get to work back to the cross section, which will be whatever is a square, so be the square root of the area, something like that. And well, we've so the factor of safety there is 6. Factor of safety equals 6. Now, the safe work and stress equals the ultimate tensile strength divided by the factor of safety. Right, so the ultimate is 21 meganewtons, 21 by 10 to the 6, divided by 6, and that comes out to be 3.5 by 10 to the 6 newtons per square meter. That's the safe work and stress, right? And we're asked we need to get the area, calculate the cross section, but first of all we need to get the area of each leg. So stress equals force divided by area, right? Now, if we multiply both sides by A here, you'll end up with sigma times A equals force. And if we divide both sides by A here, you'll end up with sigma equals, back up the horse again. We want to get A on its own, so divide both sides here by sigma, and they'll cancel, and we're left with A equals F divided by sigma, right? So that we can get the area. Now, the load is 20,000, but with 4 legs, so the load per leg we've already worked it out at 5,000. So that'll be our force here. So our area will be equal to 5,000 divided by our safe work and stress. For sigma, we'll go into safe work and stress. 3.5 by 10 to the 6. So we have 5,000 divided by 3.5 by 10 to the 6. And that comes out to be 1.428 by 10 to the minus 3. And that's squared meters. That's the area for one leg, the cross-sectional area for one leg. Now, imagine this is our leg cross-section. And we could call that side X. Well, each side is going to be X. We're looking for the cross-section, which means we want to know what the length, what side of this square. So X squared equals 1.428 by 10 to the minus 3. Well, X is going to equal the square root of that. And if you bring that into the calculator, that comes out to be accurate to 1 decimal place after pressing the eng key and everything. Well, let's do it, sure. Look. And put in again here. 1.428 by 10 to the minus 3, the square root of that. And we eng that answer there. And to 1 decimal place, 37.8 by 10 to the minus 3. And that's meters. That's the length of the square. That's the length of the side, each side of the square. And that agrees with the answer given there in the tutorial question.